I'm Mr. Joseph, your chemistry teacher, still on alkenes and reactions of alkenes, basically electrophilic addition of what alkenes with a hydrogen halide. Now the question before us is a typical chemistry A-level question. The structure of compound X is shown. You can see the structure of compound X. 1 mole of compound X reacts completely with 2 moles of hydrogen bromide. What is the structure of the major product of this reaction? So this is electrophilic addition of what? A hydrogen halide to what? To an unsymmetrical what? Alkane using Markovnikov's rule. Based on Markovnikov's rule, when a hydrogen halide is bonded to what? An unsymmetrical alkene, the addition reaction takes place between the carbon double bond carbon. Two products are usually formed. One is the major product and the other is the minor product. The major product is the one where the halogen is bonded to the carbon with the least hydrogen atom, and the hydrogen is bonded to the carbon with the most hydrogen atom. While the minor product is the one where the halogen is bonded to the carbon with the most hydrogen atom, and the halogen is bonded to the carbon with what? The least hydrogen what? Atom. So if you look at the structure before us, let's analyze the structure before us. At the addition reaction takes place between the carbon double bond what? Carbon. So if you look at this, here we have a carbon, and you also have what? A carbon, the bond what? Carbon. So you are going to add what? Hydrogen chloride here, hydrogen bromide, which is the hydrogen halide. Now if you look at this place, so we have what? Here is CH, and here is just what? C. So based on Markovnikov's rule, the major product is the one where the halogen is bonded to the carbon with the least hydrogen atom. So if you look at this carbon, it has one hydrogen atom. This carbon have one hydrogen atom, while this carbon has no hydrogen what? Atom. So the major product will be the one where the halogen, which is the bromide ion, the bromide will be added to the carbon with the least hydrogen. So you have the bromide here. Then the hydrogen will be added to the carbon with the most. So here will become what? CH2. Then if you come to this is where we have carbon, the bond what? Carbon. So here we'll have what? CH2. Then at this point we'll have what? CH. So you are adding hydrogen bromide, which is HBr. So what happened is what? The major product is the one where the halogen is bonded to the carbon with the most hydrogen. So with the least hydrogen, where the major product is the one where the halogen is bonded to the carbon with the least hydrogen. So this is the way you add, bromine will be added, and the hydrogen will be added to this. Here will become what? CH3. So you can see based on Markovnikov's what? Markovnikov's rule. So the major product, if you look at the options A, B, C, D, and from what we've just done here, you discover that the correct answer to this question is what? A, which is the correct answer. A is the correct answer. B is wrong because B is also wrong because the halogen is bonded to the carbon with the most hydrogen. No, so it will not be the major product. So that's why B is what? Wrong. If you look at D, the halogen is bonded here. The halogen is bonded to the carbon what? The carbon with the most hydrogen is also wrong. And here the halogen is also what? Bonded. So D is also wrong. If you look at C, the halogen is not bonded to the what? To the right carbon atom. So here the halogen is not bonded to the right carbon atom. So the correct answer is what? A, and not what? Neither B, nor C, nor D. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on alkenes and reactions of what? Alkenes. Where these are typical chemistry A-level questions on electrophilic addition of what? Alkenes. Limonene is found in lemon and orange oils. You can look at the structure of limonene. What is the major product when limonene reacts with an excess of dry hydrogen chloride? This is an electrophilic addition reaction of what? Alkenes with hydrogen halide, whereby two products are formed. One is the major product and the other is the minor product. You are adding a hydrogen halide. You're adding a hydrogen and a halogen. The major product is usually the one where the halogen is bonded to the carbon with the least hydrogen atom, because the addition reaction takes place between the carbon double bond carbon, where you use what? An unsymmetrical alkene. So the major product, based on Markovnikov's rule, the major product is usually the one that is formed where the halogen is bonded to the carbon with the least hydrogen atom, and the hydrogen is bonded to the carbon with the most hydrogen atom. While the minor product is the one where the halogen is bonded to the carbon with the most hydrogen atom, and the halogen is bonded to the carbon with the least hydrogen atom. So if you look at the structure before us, we have to analyze the structure before us based on Markovnikov's rule. The electrophilic addition reaction takes place between the carbon double bond carbon. So in between the carbon double bond carbon, we'll have what? Here we'll have CH. Here we'll have CH. Here is what C. So you are adding hydrogen chloride, which is a hydrogen halide. Based on Markovnikov's rule, the halogen and the hydrogen will be bonded to what? The carbon, each of the carbon double bond carbon. Based on Markovnikov's rule, the major product is where the halogen is bonded to the carbon with the least hydrogen. Now, if you look at this carbon have one hydrogen, while this carbon doesn't have any hydrogen, zero hydrogen. So the major product is the one where this halogen will now be bonded to this, which is Cl. Then the hydrogen will be bonded to this, so then you have CH2. Then addition reaction will also take place here because we have a carbon double bond carbon. This is CH2 and this is what? C. So you have a C here, then you have what? CH2 here. So the major product is the one where the carbon is, when the halogen, so you're adding a hydrogen chloride. The major product is where the halogen is bonded to the carbon with the least hydrogen. So you can see that this carbon has the least hydrogen because there's no hydrogen here. So this chlorine is bonded to this carbon, and then the hydrogen will be bonded to here. Here will be what? CH3. So from what we've just done, if you look at the structure, the correct answer to this question is what? C, because the halogen is bonded to the carbon, this carbon, and the halogen is also what? Bonded to this what? Carbon. So C is the correct answer. You can see that A is not the correct answer. A is wrong. The reason A is wrong because there is no addition of what? The hydrogen what? Halide to this carbon double bond carbon. So A is wrong. Then if you look at B, there's no addition of the hydrogen halide to this carbon double bond carbon, and also what? The halogen is bonded to the carbon with the most hydrogen, which is wrong. Then if you look at D, the halogen chlorine is bonded to the carbon with the most hydrogen atom, which is wrong. And also the halogen is not bonded to what? The actual position, so which is also what? Wrong. So the correct answer to this question is what? D. Is C, I mean to say the correct answer to this question is C. A is wrong, B is wrong, and D is wrong. So the correct answer is what? C. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. Thank you. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on alkenes and reactions of the alkenes. Now, before us is a typical examination question that has to do with reactions of the alkenes. The alkane shown reacts with an excess hydrogen bromide via an electrophilic addition reaction. What is the major product form? In electrophilic addition of alkane, if an alkane is added to a hydrogen halide, two major products are usually formed. If the alkane is an unsymmetrical alkane, two major products are usually formed. One is the major product and one is the minor product. Based on Markovnikov's rule, the major product is where the halogen is bonded to the carbon with the least hydrogen atom. In electrophilic addition reaction takes place between the carbon double bond carbon. If the carbon double bond carbon are what? Unsymmetrical, whereby each of the carbon atoms is bonded to different hydrogen atoms, it will undergo what we call what? Markovnikov. It will undergo electrophilic addition by Markovnikov's rule, whereby you have the major product and the minor product. The major product is the one where the halogen is bonded to the carbon with the least hydrogen atom, while the minor product is the one where the halogen is bonded to the carbon with the most hydrogen atom. So you are not asked what is the major product form. So the first thing to do is to write the display formula of the compound that is shown. Then we'll now carry out the reaction. We'll now add what? A hydrogen what? Halide. Now let's draw the display formula. It's very, very important. So the display formula, this is CH3. C, then CH3, double bond C, then you have H, single bond C, you have this CH2, then you have C, CH, double bond, You have H and you have what? H. Now, this is the display formula of the molecule before us. So we want to identify the major product form when it undergoes electrophilic addition with what? Hydrogen bromide. You know, addition reaction takes place where you have the carbon to bond carbon. So if we add hydrogen bromide here, based on Marconi-Cross rule, the major product will be the one where the halogen is bonded to the carbon with the least hydrogen atom. This carbon has the least hydrogen atom. This carbon have one hydrogen atom, but this carbon have no hydrogen atom. So this is the carbon that have the least hydrogen atom. So the bromine molecule will add here. So you have this. Then if you come to this place, we'll add hydrogen bromide, HBr. This is the carbon with the least hydrogen. This carbon has two hydrogen atoms. This carbon have one hydrogen atom. So the bromine atom will be at this point. So if I remove the double bond, make a single bond, make a single bond. So I'm to name the molecule now. What is the major product? The major product is where the halogen is bonded to the carbon with the least hydrogen. So this is the first carbon atom, second, third, fourth, fifth, and sixth. So it will be what? 2 bromo, 2, then 5, 2, 5, dibromo, then 2 methyl hexane, because we have 6 carbon atom, 1, 2, 3, 4, 5, 6, 2, 5 dibromo, 2 methyl hexane. So what is the major product form? So the major product form is 2, 5 dibromo, 2 methyl hexane. So the correct answer to this is what? B. So the answer to this question is B. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm Mr. Joseph, your chemistry teacher. Still on alkenes and reactions of the alkenes. We all know that the major reactions of the alkenes has to do with electrophilic addition. We'll talk about oxidation, reaction, combustion, but the major one is electrophilic addition. So this is a typical A-level chemistry question. Which compound has an MR of 84 and will react with hydrogen bromide to give a product with an MR of 164.9? So we look at the option. You know, the major reactions of the alkenes has to do with electrophilic addition. So if you look at the option, that the compound reacts with what? Hydrogen halide, which is hydrogen bromide. So A is out of it. A is out of it. A is not the answer because A is cycloalkane, and cycloalkane, they don't react with what? Hydrogen bromide. So A is out of it. Then let's look at B. B can react with hydrogen bromide through electrophilic addition, but we'll have to calculate the molar mass of B. So I have to write out the structural formula, which is CH3, CH2, CH2, CH, double bond, CH, then you have CH2, then you have CH3. So let me calculate the molar mass. 1, 2, 3, 4, 5, 6, 7. So 7 carbon atom, carbon is 12, 7 bracket 12, plus hydrogen 3 plus 2, 5 plus 2, 7, 8, 9, 9 plus 2, 11, plus 14. So you get what? 98. So B is not the answer. The molar mass of B is 98, not 84. So B is out of it. Then let's look at C. If you look at C, C is a ketone. And ketone doesn't undergo electrophilic addition with hydrogen bromide. Ketones undergo nucleophilic what? Addition. So C is out of it. I think the answer should be D. D is the correct answer. Just to prove that D is the correct answer. So what I will do is I'm going to draw the display formula, the structural formula of D, which will be CH3, then CH2, then you have CH, then we bond CH, then you have CH2, then you have what? CH3. So let me calculate the number of carbon. 1, 2, 3, 4, 5, 6. 6 carbon atom, which is 6 bracket 12, plus hydrogen. Let me calculate the hydrogen. 3 plus 2, 5, 6, 7, 7 plus 2, 9, 9 plus 3, which is what? 12. So, which is 6 bracket 2, which is equal to 72. 6 times 12, 6 bracket 12, 6 times 12, which is 72. 72 plus 12, which is equal to 84. Plus 12 is equal to what? 84. So the correct answer is what? D. D is the correct answer. The compound has an MR of 84 and it will react with HBr because it's an alkane. So it will undergo electrophilic addition with hydrogen bromide to give a product with molar mass of 164.5. Because 84, if you look at 84, 84 plus 79.9 plus 1 is equal to it to give you 164.9. So the correct answer to this question is D. So it's as simple as what? A, B, C. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me if you encounter any difficulty. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you very much. I'm Mr. Joe, your chemistry teacher. So still on alkenes and reactions of the alkenes. Before us, a typical A-level chemistry question on alkenes and the reactions of alkenes. The major reactions of the alkenes have to do with the electrophilic addition and oxidation reaction using acidified potassium manganate 7 solution. So the question before us, 2-methyl-butyene is reacted with hot concentrated acidified potassium manganate 7 solution. What are the products of this reaction? You know, alkenes undergo oxidation reaction using acidified potassium manganate 7 solution. So the product that is formed depends on the condition. Depends on the condition of the oxidizing agent, which is acidified potassium manganate 7 solution. And the condition here is what? Hot concentrated acidified potassium manganate 7 solution. So for us to answer this question, the first we have to draw, the display formula of the molecule, which is 2-methyl-butyene. So you have 1, 1, 2, 3, then 4. So this is 2-methyl. Okay, 1, 1, 2, 2-methyl. Okay. So I have to draw the display formula. I have to draw the display formula. Okay. Yeah, this is 2-methyl, 2-methyl-butyene. So we're using hot concentrated acidified potassium manganate 7 solution. So it depends on the alkane. And the reaction takes place in between the carbon double bond carbon. If the carbon double bond carbon, if one of the carbon is bonded to one hydrogen atom and one alkyl group, you get oxidation to a carboxylic acid. If the carbon atom is bonded to 2 hydrogen atoms, you get oxidation to carbon dioxide. If the carbon atom is bonded to 2 alkyl group, get oxidation to what? A ketone. So if you look at this carbon, it's bonded to 1 hydrogen atom and 1 alkyl group, so you get oxidation to a carboxylic acid, which is CH3 COOH, which is ethanoic acid. And this carbon atom is bonded to 2 alkyl groups, so you get oxidation to what? A ketone, which is CH3 CO, then CH3. So what are the products of this reaction? The products of this reaction are what? Ethanoic acid and what? Propanone. Ethanoic acid and propanone. So the correct answer to this question is what? B. B is the answer, which is ethanoic acid and what? Propanone, because the carbon is bonded to 1 hydrogen atom and 1 alkyl group, so you get ethanoic acid. This carbon atom is bonded to 2 alkyl group, you get what? Propanone. So it's as simple as what? A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge, any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. So feel free to reach out to me, and I'll be there for you. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.